So the next topic in modern physics is nucleus. Atomic structure we have studied now, structure of atom. Clear? So in structure of atom what we have studied about different theories we have studied now. J.J. Thomson's theory, Rutherford's, Niels Bohr. Then we have calculated some parameters, all that we have studied in atomic structure. Then we will study about the nucleus and its components. Clear? So nucleus consists of what? Nucleus consists of protons and it consists of neutrons. Clear? No? So protons, positively charged particles, they are having positive charge, no? And what is the charge of a proton? Proton ki enta charge untundi cheppandi. Charge of proton will be how much? Same. Charge of proton and charge of electron both are same. So charge of proton is nothing but charge of electron. This is equals to 1.6 into 10 power minus 19 coulombs. So this is the charge of a proton, and same charge exists for a electron also. Clear? Similarly, mass of proton is how much? Mass of proton, I can say it is 1.6726 into 10 power minus 27 kg. So that is the mass of proton. Are you able to understand now? So in atomic mass units, if I want to write approximately 1.0078 atomic mass units. So that is the mass of a proton. Okay. In terms of atomic mass units, this many atomic mass units, almost equal to 1 AMU, 1 atomic mass unit, slightly greater. How much? 0.0078 AMU, slightly greater than 1 atomic mass unit. 1 atomic mass unit means 1, no? Mass of proton is slightly, very slightly greater than 1 AMU. Almost you can say it is approximately equal to 1 AMU also you can call it. Approximately equal to 1 AMU. Are you able to understand? And when compared to mass of electron, mass of proton is nearly 1836 times the mass of an electron. Okay. So when compared to mass of electron, mass of proton is how many times bigger? 1836 or 1837 times bigger when compared to mass of electron. So electron mass to compare just the inherently peddaga untundi. It means it is a very, very small mass. No? Mass of electron is very, very small. Are you able to understand? No? So mass of electron is how much? Mass of electron in terms of atomic mass units you can write 0.00055 atomic mass units. Very small. Okay. See the mass of proton 1.0078, but this is 0.00055 atomic mass units. So mass of electron is very small. Clear now? Similarly, if I want to write mass of electron in terms of kgs, I can write 9.11 into 10 power minus 31 kg. This is the mass of an electron. Okay. Similarly, now if I want to write about neutron, okay, ma? Neutron, this is a neutral particle. That is why it is given the name neutron. Neutral particle. What is meant by neutral particle? Ma? Neutral particle means it doesn't have any charge. Charge of neutron is not there. So it doesn't have any charge. Only protons and electrons, they are charged particles. Neutrons doesn't have any charge. Clear? So if I want to calculate the mass of neutron, approximately it is 1.0083 atomic mass units. So again you can say this is almost equal to 1 AMU. Almost equal to 1 AMU, but slightly greater than 1 AMU. So you can say almost it is equal to 1 AMU. Okay. And see, compare here the mass of proton is how much? 1.0078, but this is 1.0083. It means when compared to what you call proton, neutron is slightly heavier. Again you can say it is almost equal to the mass of proton. Almost equal, but slightly greater. Okay. And neutron you can split into proton and some another particle also. Okay, ma? That we will study later. Okay. And if I want to write its mass in terms of kgs, mass of neutron can be written as 1.6750 into 10 power minus 27 kg. So this is the mass of neutron. Okay. Again you can compare here, mass of proton 1.6726, but mass of neutron is 1.6750 into 10 power minus 27 kg. Are you able to understand now? So these are about the particles which are present inside the nucleus, proton as well as a neutron. Okay, make a note of 2 here. Number. So what is meant by atomic number? The number of protons present inside the nucleus. So it is not mass of protons. Mass of protons is not called as atomic number, or proton number also you can call. Just the number of protons, how many protons are present. 2 proton, 3 proton, 20, 30, 40, how many protons are there? That number is nothing but proton number, or you can call it as atomic number. And atomic number is represented by Z here. For example, if you take hydrogen, how many protons are there? Only 1 proton is there. For example, if you take a calcium, how many protons are there? Calcium, 20 protons are there. Are you able to understand? Ma? For example, if you take a gold, how many protons are there? Gold. How many protons? 79 protons are there. Okay, ma? So atomic number is nothing but number of protons. That's it. In electronic configuration, we take atomic number only, no? Okay, ma? Atomic number is nothing but what? Number of protons only. Number of protons which are existing inside the nucleus. Okay. So therefore, then we study about mass number. Okay, ma? So what is meant by mass number? Mass number, it is represented by A. Okay. So it is the sum of protons plus neutrons. Okay, ma? So or you can say total number of protons and neutrons, that is called as mass number. Are you able to understand? So for example, you count the total number of protons and neutrons which are present inside the nucleus. So that total number of protons and neutrons is nothing but mass number. For example, if you take calcium, atomic number is 20. Mass number may be some 40. Okay. So 40 means what? 20 protons are there, 20 neutrons are there. That is the meaning of it. Are you able to understand? And it is represented by A. So therefore, how to denote an element? Denoting of an element. How can I denote an element, ma? So I can write X, A, Z. This is how I denote an element. Are you able to understand, ma? For example, if I take carbon, so I will write atomic number here and I will write mass number here. Okay. So there are many isotopes of carbon, ma. C610 is also present, C611 is there, C613 is there, C614 is there. That's all, up to here. Are you able to understand, ma? So these many isotopes of carbon is present. So all of them, they are carbon only. And what does 6 represent? Number of protons. If number of protons changes, element will change. Are you able to understand, ma? If number of protons will change, element changes completely. 6 కాకుండా 7 రాసినారు అనుకోండి ఏమవుతుంది? It becomes nitrogen. Are you able to understand, ma? So properties of elements depends on what? Properties of elements only depends on number of protons only. Are you able to understand? It doesn't depend on number of electrons, it doesn't depend on number of neutrons. Properties of element depend only on number of protons itself. Okay? Because unless it is 6, then only it becomes carbon. ఒకటి పెంచినారు అనుకోండి అది నైట్రోజన్ అయిపోతుంది, ఒకటి తీసేసినారు అనుకోండి అది బోరాన్ అయిపోతుంది. అర్థమవుతుంది కదా? దట్స్ ఇట్. But these are different isotopes. So C612 is also present. What is meant by C612? 6 protons are there, 6 neutrons are also present. 6 plus 6, 12. This is mass number. No? And again, what is meant by 610? 610 means what? 6 protons are there, only 4 neutrons are present. Because 6 plus 4, 10, like this. Are you able to understand, ma? So therefore, this is the method of denotation. Here I have to write atomic number, here I have to write mass number. Is it clear? Okay. So then we will discuss about some of the very important types of elements called isotopes, isobars, and isotones. Clear, ma? So therefore, what is meant by isotopes? Isotopes means what, ma? Elements with same atomic number, but different mass number. Okay, ma? Different mass number, they are called as isotopes. It means atomic number should be same, mass number should be different. Just now we have written an example, no, ma? Isotopes of carbon, if I take carbon 610, carbon 611, carbon 612, carbon 613, carbon 614. So these are some of the examples of isotopes. All of them you can call them as isotopes. Are you able to understand, ma? Because their mass numbers are different, atomic numbers are same. Clear? Similarly, you can write hydrogen 11, hydrogen 12, hydrogen 13. Okay, ma? So actually this you can call it as hydrogen, and this one you can call it as deuterium, and this one you have to call it as tritium. Are you able to understand? So, but atomic numbers are same, no? 111. Mass numbers are different. So this is called as an isotopes. These are some of the examples of isotopes. Clear, no? So then we study about isobars. Isobars. Okay. Isobars with means what? Elements with same mass number. Mass number is same, but a different atomic number. Are you able to understand, ma? So mass number should be same, but atomic number should be different. Such type of elements you can call them as isobars. Examples we will write here. For example, if you take the example of argon and calcium. Okay, ma? Atomic number is 18, atomic number of calcium is 20. Its mass number can be 40 and its mass number also can be 40. Okay, mass numbers are same, no? But atomic numbers are different. So this is one example of a isobar. Are you able to understand? Clear, man? Similarly, if I take sodium and magnesium also. Sodium and magnesium. Sodium atomic number 11, mass number, atomic number of magnesium is 12. Mass number of sodium can be 23, mass number of magnesium also can be 20. So mass numbers are same, atomic numbers they are different. Vivek, rasta unnava? Notes rasta unnava? Pending unte idu kuda pending pettukunte etla? Okay, that's it. So next we study about the third type of element, which is called as isotones. Clear? Isotones means what? Elements with different mass number and different atomic number, but same neutron number. Okay, ma? So this type of elements we can call them as isotones. Clear? So mass numbers are also will be different, atomic numbers also will be different, but a number of neutrons will be equal. So that type of element I can call it as what? Isotones. Okay, ma'am? So example of this one we will write here. Examples are, for example, if you take hydrogen 1,3, which is called as tritium, helium 2,4. This is one example, no, ma'am? Okay. For example, if you see here, 1,3, 2,4, 1 and 2, they are different. Atomic numbers are different. 3, 4, mass numbers are also different. But if you do 3 minus 1, what you will get? You will get 2. And what is this 2? This 2 is number of neutrons. That's all, no? From mass number, if you remove atomic number, remaining is number of protons or neutrons only, no? Clear, no? Similarly, 4 minus 2, then also I will get a 2 only. And what is 2 again? Again it is number of neutrons. So like this you can write many examples. Are you able to understand, ma? So mass numbers also should be different, atomic numbers also should be different, but number of neutrons should be same. That is called as isotones. So these are some of the examples. Clear now? Sometimes direct questions will be asked on them. Clear? So you should be careful about them. Okay. So then we study about atomic masses. Clear now? So atomic mass. Okay. So atomic masses are very small. Okay, ma? Therefore, they are measured in what? They are measured in atomic mass units, AMU. Okay. AMU you can also call them as unified mass also. Okay, ma? So mass of, for example, if I want to calculate mass of proton, it's a very small value, no? You cannot measure it in grams or kgs. Gramలలో kgలో measure చేయాలంటే చాలా కష్టం. Clear number? So we measure the masses in atomic mass units, which are very small units. Okay. Now what is meant by 1 AMU? We will write the definition of 1 AMU. Okay. So it is the mass of 1/12th of mass of C612 isotope. Are you able to understand, ma? So how I define 1 AMU, ma? Previously, mass of hydrogen was taken as 1 AMU. Previously, when we were studying, there was no concept of carbon. Then we were studying that mass of hydrogen is 1 AMU. But technically there were some problems, so they changed to carbon. Okay. So 1/12th mass of C612. There are many isotopes of carbon, no? C6, 10, 11, 12, 13, 14 are present. Which isotope I have to take? That isotope whose atomic number is 6, mass number is 12. That isotope. So, and in that atom, how much part I have to take? Only 1/12th part of that one particular single atom. Okay, ma? So this is what? This is only one atom. One atom of C612. ఆ ఒక్క atomలో మళ్ళీ ఎన్నో భాగము? 12th part. 1/12th part if I take, then that amount of mass is defined to be 1 AMU. Are you able to understand? So therefore, what is the mass of 1 C612? Can you say? ఒక కార్బన్ ఆటం మాస్ ఎంత ఉంటుంది మరి? 1/12th mass of carbon C612 is called 1 AMU. 12వ భాగాన్ని ఒక AMU అన్నాం. Then what is the mass of one carbon atom? 12 AMU. That's all, no? ఏవైతున్నారు మీరు? Okay, ba? 12 AMU. Understood, no? Mass of 1/12th part is 1 AMU. మరి ఒక కార్బన్ ఆటంకి AMUs ఎన్ని ఉంటాయి? 12 AMU. That is the mass of one carbon atom. Are you able to understand, ma? Then we know molar mass, no? Molar mass of carbon or molecular weight of carbon. Molar mass of carbon is how much? 12 grams, no, ma? Molar mass of carbon is 12 grams. So here the discussion is very, very, very important. Useful both in physics as well as in chemistry. So listen very carefully. So mass of one carbon atom is 12 AMU. Molar mass of carbon 12 grams. So what is the difference between AMU and grams? నిన్న కూడా మొన్ననో ఎప్పుడో ఈ డిస్కషన్ జరిగినట్టుంది ఆల్రెడీ. అర్థమవుతుందా? మాస్ ఆఫ్ వన్ కార్బన్, వన్ సింగిల్ కార్బన్ ఆటమ్ ఈజ్ 12 AMU. క్లియర్ నో? బికాస్ 1/12th మాస్ ఈజ్ టేకన్ యాజ్ 1 AMU. కార్బన్లో 12వ భాగాన్ని తీసుకుంటే దాన్ని ఒక AMU అనుకున్నాం. దెన్ వాట్ ఈస్ ద మాస్ ఆఫ్ టోటల్ వన్ కార్బన్ ఆటమ్? 12 AMU. అంతే కదా? ఓకే, అర్థమవుతుందా? ఉమేష్ని 4 భాగాలు చేసినారు మర్డర్ చేసి. ఒక్కొక్క భాగం 10 గ్రాములు ఉందనుకున్నాం, మరి అంత తక్కువ ఉండాలి. ఒక్కొక్క భాగం వచ్చేసి 3 kgs ఉంది. 4 భాగాలు చేసినాం. మరి మొత్తం మాస్ ఎంత ఉంటుంది? 4 3 are 12 ఉంటుంది, అంతే కదా. మరి అదే కాన్సెప్ట్ ఏది అంతగా ఆలోచిస్తూ ఉన్నారు? 12th mass of carbon is taken as 1 AMU. Are you able to understand, ma? Then what is the mass of total carbon? 12 AMU. Understood, no? So mass of single carbon atom is 12 AMU. Then molar mass of carbon 12 grams. You know this one already, no? In chemistry you should have studied, no? Molecular weight of carbon or molar weight of carbon is how much? 12 grams. Now what is meant by 12 AMU? What is meant by 12 grams?
12 grams and 1 mole.
12 grams means 1 mole. 1 mole means what?
6.0.
No, 6.0. What is that? ఈ రెండింటికి డిఫరెన్స్ చెప్పండి చాలా. 12 AMU అంటే ఏమని? దిస్ ఈజ్ ద మాస్ ఆఫ్ 1 atom. ఓకే, వాట్ ఈస్ దిస్ వన్? This is the mass of 1 atom. Molar mass means what? Mole means 6.023 into 10 power 23 atoms. It means if you take the mass of not single atom, how many atoms? Mass of 6.023 into 10 power 23 atoms of carbon if you take, then their total mass will be 12 grams. That is the meaning of it. అర్థమవుతుంది కదా? So therefore this is the 12 grams is the mass of how many atoms, ma? This is the mass of, okay ma, mass of 6.023 into 10 power 23 atoms of what? C612. Okay, that is the difference. That is the difference between AMU and grams. If you are writing in AMU, it means that that is the mass of single atom or single molecule. Okay, but if you are writing the same value in grams, then it means that you are taking the mass of how many atoms? These many atoms. Inni atoms mass kalipite oka molar mass అవుతుంది, and that is exactly equal to the same numerical value. ఇక్కడ 12 వస్తే ఇక్కడ 12 వస్తుంది. For example, if you take oxygen, what is the molar mass of oxygen? 16 grams. 16 grams. What is meant by 16 grams? You take the mass of 6.023 into 10 power 23 atoms or atoms of oxygen. Are you able to understand, ma? 6.023 into 10 power 23 atom, అన్ని atoms తీసుకుంటే వాటి మొత్తం mass will be how much? It will be 16 grams. Then what is the mass of single oxygen atom? 16 AMU. That's it. Are you able to understand, no, ma? That is the difference between AMUs and representation in grams. Clear? So therefore, for example, here I can write down. So mass of 1 atom of oxygen is how much? It is 16 AMU. Okay, ma? Mass of 6.023 into 10 power 23 atoms of oxygen is how much? It is 16 grams. That's it. That is the difference. Clear, number? Sima, grams is a very, very, very big unit when compared to AMU. AMU to compare cheste, grams is a very, very big unit. Because AMU is the mass of single atom, but grams is the mass of these many atoms. Inni atoms mass తీసుకుంటే 16 grams. Okay? So to make calculations easy, so this number is taken. 6.023 into 10 power 23. Why it is taken? So that there is some symmetry between AMU and grams. AMU నాట నంబర్ ఎంత ఉంటుందో గ్రామ్ నంబర్ కూడా అంతే ఉండాలి. అలా ఉండాలి అంటే డెఫినెట్లీ యూ హ్యావ్ టు టేక్ అవగాడ్రో నంబర్. దట్ ఈస్ వై ఓన్లీ దిస్ నంబర్ ఈస్ టేకన్ యాజ్ అవర్ స్టాండర్డ్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? దట్స్ ఇట్. సో దట్ ఈస్ అబౌట్ మాలిక్యులర్ మాస్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? Okay, completed now up to here. So therefore what I have written, mass of these many atoms of carbon is equal to 12 grams, no? Therefore what I do, therefore mass of 1 atom of carbon C612 will be how much, ma? it will be equal to 12 grams divided by, now I have to multiply with, divide by which number? 6.023 into 10 power 23. So if I calculate this one, I will get mass of single atom of carbon. Are you able to understand? Single atom of carbon, I know it is 12 AMU. Already I know this value. Okay. But now I am trying to calculate in terms of kgs and grams. Okay. So mass of these many atoms of carbon is 12 grams. Then mass of single atom of carbon, ఒక atom carbon ki mass ఎంత ఉంటుంది? 12 grams divided by this number, 6.023 into 10 power 23 grams. Okay. So this one, if I multiply by 10 power minus 3, then what happens? So therefore it converts into kgs. That's all, no? Because 1 gram is how many kgs? 1 gram is 10 power minus 3 kgs. So if I multiply this total value by 10 power minus 3, it converts into kgs. Are you able to understand, ma? So therefore, so this is the mass of carbon C612. Then 1 by 12th mass of C612 is called what? 1 by 12th mass of C612 is called what, ma? It is 1 AMU, no? Okay. So therefore this total value I have to divide by 12, no? This total value, if I divide by 12, then it is nothing but 1 AMU. That's all. So therefore what I do, 12 into 10 power minus 3 divided by 6.023 into 10 power 23 multiplied by 12, then it totally converts into kgs. Are you able to understand? Now if I do this total calculation, I will get it is 1.66 into 10 power minus 27 kg. Okay. So why I have done this total calculation? To calculate, to convert AMUs into kgs. Okay, ma? 1 AMU is equal to how many kgs? These many kgs. 1.66 into 10 power minus 27 kg. Okay. And this is approximately mass of proton. And again approximately the mass of neutron also. And approximately the mass of hydrogen atom also. Are you able to understand, ma? Mass of proton is how much? 1.6726. Almost equal to 1.66. What is the mass of neutron? 1.6750 multiplied by 10 power minus 27. This is also almost same. So 1 AMU is almost equal to mass of proton, almost equal to mass of neutron, almost equal to hydrogen 1,1 isotope. Understood, no? That's it. So have you understood the calculations, ma? How we got to this result? Once go through these steps carefully, then very easily you can understand. Okay. And these calculations are very, very important one. Totally you understand the basics of AMU here. Okay. Otherwise you cannot do many problems of physics as well as chemistry also. Okay. అంటే న్యూటన్ పెళ్లి చేసుకోలేదు ఎప్పుడు. న్యూటన్ నెవర్ మ్యారీడ్. సో బ్రహ్మచారిగా ఉన్నాడు అనమాట ఇప్పుడు. 83 years ఎంతో బతికినాడు ఆయన. ఆ వయసు వరకు కూడా హీ రిమైండ్ టు బి బ్యాచులర్. సో బ్రహ్మచర్యం వహించిన వాళ్ళకి ఆ ఇంటెలిజెన్స్ లెవెల్స్ని ఎవరు తట్టుకోలేదు. అది చాలా ఎక్కువగా ఉంటుంది. Are you able to understand? Once a person starts practicing this brahmacharya, లేడీస్కి ఆప్షన్ ఉండదు. మీరు బ్రహ్మచర్యం పాటించినా పాటించకపోయినా మీకు అంతే ఉంటుంది. క్లియర్? దట్ ఈస్ ద గిఫ్ట్ ఓన్లీ ఫర్ మేల్స్ ఓన్లీ. సో వన్స్ దే ప్రాక్టీస్ దిస్ థింగ్, దేర్ ఇంటెలిజెన్స్ లెవెల్ బికమ్స్ మల్టీఫోల్డ్. 2, 3, 10, 20, 100 రెట్లు పెరుగుతాయి. సో దట్ వాస్ ద ప్రాక్టీస్ ఆఫ్ న్యూటన్. సో దట్స్ వై there is no branch of science in which he did not enter. Maths, physics, chemistry, biology, ఏది పడితే దాంట్లో దూరేసాడు ఆయన. And almost all the principles, even they are correct today also. So he is considered to be the most intelligent, and next person is Einstein in total history of great people of scientists. Clear, no? So Einstein's mass energy equivalence. See, he derived a very beautiful relation and one of the most easiest as well as toughest relation. Relation is very easy because just it can be written E is equal to mc square. Very easy to use, no? But where we use this one, this is very tough. Okay. So he said that mass and energy are how can you say, are one and the same. Okay, ma? It means that mass you can convert into energy. Energy also you can convert into mass. Are you able to understand, ma? Mass ni meer energy ga marchochu, energy ni kuda mass ga marchochu. So therefore he did not differentiate between mass and energy. Mass is a form of energy or radiation. Light is a form of energy, no ma? Light is a form of mass. Mass, if you can light, if you can condense it, you can convert it into mass also. But methods of conversion we don't have. But some scientists, they proved it also. So continuously they incident some radiation on a particular metal, then they counted the number of electrons. Then after some time they found that the number of electrons have increased. Okay, ma? It proves that light energy also can be converted into mass. But suitable means and methods we still don't have. Are you able to understand? So mass and energy, they are interconvertible. That is the statement which was given by Einstein. Clear? So therefore here, in terms of nucleus, we can say that M is the mass disappeared. Okay, ma? M is what? M is the mass which has disappeared. For example, if you take carbon nucleus. Okay, ma? Carbon nucleus is made up of what? Carbon nucleus lo em untayi cheppandi. There are many small particles. Major particles are protons and neutrons. There are many other particles also which doesn't have considerable mass. Are you able to understand, ma? So 6 protons will be there and 6 neutrons will be present in C612 isotope. And if you count the masses of protons individually, mass of protons if you count individually and mass of neutrons if you count individually, how many protons are there? 6 protons and 6 neutrons individually. Are you able to understand, ma? And you take the mass of carbon nucleus. In carbon nucleus also how many protons are there? 6 protons are there, 6 neutrons are there. But mass of this combined nucleus, it is always less than the individual particles. అర్థమవుతుంది కదా? ఇండివిజువల్ పార్టికల్స్ మాస్ తీసుకుంటే కార్బన్ న్యూక్లియస్ మాస్ ఎప్పుడు తక్కువగా ఉంటుంది. ఇట్ మీన్స్ సమ్ ఆఫ్ ద మాస్ హ్యాస్ డిసపియర్డ్. నో, సమ్ ఆఫ్ ద మాస్ హ్యాస్ డిసపియర్డ్. అండ్ వాట్ హ్యాపెండ్ టు దట్ మాస్? So that disappeared mass has converted into energy. That is the statement which was given by Einstein. Are you able to understand, ma? For example, so that we will discuss in mass defect, ma. Now here we will limit our discussion up to here. So M is called what? M or delta M is called as mass disappeared, and E is called what? Energy converted, energy obtained. Energy obtained you can call it as. Clear? And C is called as speed of light. C is called as speed of light, which is 3 into 10 power 8 meters per second. Are you able to understand? So it means if some of the mass disappears, it converts into energy. And how much energy will be released? E is equal to mc square energy will be released. Okay? Let us do a small calculation. So if 1 gram of mass is converted into energy, find energy released. Find energy released. Are you able to understand? If 1 gram of mass, if I can convert into energy, then how much energy will be released? Which equation I can use? Same, E is equal to mc square. So E is equal to mc square. So E is equals to mass is how much, ma? 1 gram. But if you want to convert into kgs, 1 into 10 power minus 3 kg. Because every value I should take in SI units only. No? And C means what? Speed of light. 3 into 10 power 8. And C square is there, no? So 3 into 10 power 8 whole square. So therefore how much it is? So 1 into 10 power minus 3 multiplied by 9 into 10 power 8 2s are how much, ma? 3 square. 16. Are you able to understand? So therefore it is 9 into 10 power 13 joules of energy. Okay. So how much energy is released, ma? 9 into 10 power 13 joules of energy. Small energy or a very, very big energy? It's a very, very huge amount of energy. Okay, ma? So this much amount of energy can be released if you can convert 1 gram of matter into energy. That's it. Clear? Similarly, if 1 AMU, which is equal to 1.66 into 10 power minus 27 kg, is converted into energy, clear number, then 931.25 million electron volts of energy is produced. Okay, ma? So this is a very, very, very important point. Okay, 1 AMU, it is also mass only, no? 1 atomic mass unit. Okay, and what 1 atomic mass unit is how many kg? 1.66 into 10 power minus 27 kg. 1 AMU of mass, if I convert into energy, then how many electron volts of energy will be released, ma? 931.25 million electron volts. So million means 10 power 6, or you can call it as mega also. 931.25 into 10 power 6 electron volts of energy will be released. Are you able to understand? This is called as mass energy equivalence, a relation between mass and energy. Okay? Nucleus. Size of nucleus. Size of nucleus depends on what? Depends on mass number. This is understandable, no? Okay, ma? Mass number depends on number of protons and neutrons only, no? So if mass number increases, automatically size of the nucleus also increases. Size of nucleus of hydrogen is very small, because only one proton will be the neutron would undadu andulo daridram. In hydrogen 1 you don't have a nucleus or neutron also, only proton is present. Similarly, if you take argon, atomic number 18, clear number? So 18 protons are there, nearly some 20 neutrons are there. Are you able to understand? 20 or 22 neutrons are there. Similarly, if you take gold, inside gold nucleus, how many protons will be there? 79 protons will be there, and very huge number of neutrons also will be there. Are you able to understand, ma? బాగానే ఉన్నావు కదా, ఎందుకు క్లాస్ స్టార్ట్ అయిపోయిన నుంచి ఇట్లున్నావు, అంతా బాగానే ఉంది కదా, ఇంటి దగ్గర ఎవ్రీథింగ్ ఈజ్ ఫైన్, నో ప్రాబ్లం, బాగానే ఉంది కదా, నో ప్రాబ్లం. ఓకే, సో see as atomic number increases, number of protons will be greater than number of neutrons will be greater than number of protons. So atomic number perige koddi, for example, if you take zinc, okay, 30 what you call protons are there, but number of neutrons are greater than 30. Are you able to understand, ma? So because as more number of neutrons increases, stability of that nucleus also increases. Are you able to understand? So therefore, what we are writing here, size of nucleus depends on mass number. As mass number increases, size of the nucleus also increases. So size is nothing but nucleus is a spherical type of body, nama. And what is the formula for volume of a sphere? 4 by 3 pi r cube. This is the equation for volume of a sphere. So this is directly proportional to A. A means what? Mass number. A ante atomic number kadakko, mass number. Are you able to understand, ma? Therefore I can write r cube is directly proportional to A. So r is directly proportional to A power 1 by 3. Okay, ma? Or I can write r is equals to r naught A power 1 by 3. This is the relation. Okay, where r naught is a constant. Okay, ma? And its value is 1.2 into 10 power minus 15 meters. So by using this equation, you can calculate the radius of any nucleus. R means radius here. Are you able to understand, ma? In some of the books it is written in capitals also. Capital R is equals to R naught A power 1 by 3, where this is equals to R. R naught is a constant, and its value is how much? 1.2 into 10 power minus 15 meters. So this is the equation by which I can calculate what? I can calculate radius of any nucleus. Understood? No? Radius of nucleus if you want to find out, then this equation you can calculate. Okay. Similarly, you can calculate a density also, density of nucleus. Okay. And the formula of density is equals to mass by volume. No? Density is equal to mass by volume. Mass means what? I can write m into A divided by 4 by 3 pi r cube. I can write like this. Listen very carefully. What is m here? Mass of total nucleus. Mass of total nucleus, how can I calculate? A means what? Mass number. It is just a number. Adoka number matrame, mass kaadu kada adi. And mass means, here A means what? Here A means number of protons plus neutrons. Clear, no? Number of protons plus neutrons is called as A, mass number. And number of protons and neutrons, I can call them as nucleons also. Nucleons. Okay? And mass of proton and neutron, almost they are same, no? Mass of proton and neutron, almost they are equal. Neutron is slightly bigger than proton, but slightly, very slightly. So, instead of protons and neutrons, just you can write nucleons. Nucleons means you will get protons also, you will get neutrons also. Are you able to understand now? And m is what? M is approximate mass of nucleon. Approximate mass of nucleon. So what is the mass of proton? 1.6726. Mass of neutron? 1.6750. Approximately you can write 1 AMU, no ma? Approximately you can write 1 A. Already we said, no, 1 AMU is almost equal to 1 mass of proton or 1 mass of neutron. And 1 AMU is how much? 1.66 into 10 power minus 27 kg. Okay. So therefore, if you take this value and if you substitute here, then you will get the density of the nucleus. Are you able to understand? So see here, I will write. Okay. So density is equals to mass. Mass is how much? 1.66 into 10 power minus 27 multiplied by mass number divided by 4 by 3 pi. And instead of r, I can write r naught a power 1 by 3, no ma? This also I can write, no? So multiplied by r naught a power 1 by 3 whole cube. Clear, no? So therefore again if I do this calculation, 1.6 into 10 power minus 27 multiplied by a divided by 4 by 3 pi multiplied by r naught cube multiplied by a. So a and a get cancelled. Okay. And r naught is a constant, no? And what is the value of r naught? 1.2 into 10 power minus 50. So therefore if you substitute that value, 1.66 into 10 power minus 27 divided by 4 by 3 pi multiplied by 1.2 into 10 power minus 15 whole cube. Okay. If you do this total calculation, then I will get approximately 2.17 into 10 power 17 kg per meter cube. Okay. Let me check it whether it is correct or not. 2.3 into 10 power 17 kgs per meter cube. So this is the density of nucleus. Understood, no? So see, the density is small or very big or very, very big. Density of water is how much? Density of water is only 10 power 3 kg per meter cube. Okay. Water em baro takku baru em undadu kada water 10 power 3 kg per meter. But see the density of nucleus, 10 power 3 akkada, 10 power 17 akkada. So the density of nucleus is very, very, very big. Okay. But density of atom is very less. Why? Because nucleus, though it is highly denser, it is a very small particle, no? And atom is mostly empty. That's what we studied in the last class, no? Atom is mostly empty. Size of atom is only because of rotation of electrons. So if you take overall density of atom, it is very less. But density of nucleus only if you take, then it is very, very large. If you consider nucleus in Talav, nucleus undanukondi, for example, దాన్ని ఒక 1000 మంది కలిపినా లేపలేరు. జస్ట్ ఇంత సైజ్ న్యూక్లియస్ ఉందంటే, because its density is very large. Are you able to understand? So that is about the size of nucleus and density of nucleus. So remember up to here, then we will continue in the next. Okay, ma? So he is asking us to find out the nuclear radius of lead and oxygen. Clear now? So yesterday what was the equation which we have studied to calculate radius? R is equals to R naught a power 1 by 3. This is the equation. So just substitute in this value. For lead, okay, no? R is equals to R naught value is 1.2 into 10 power minus 50. This already we have calculated, no? Multiplied by A means mass number. What is the mass number of lead? 208 power 1 by 3. So just do this calculation. That will be the radius of lead atom. Are you able to understand? Lead nucleus. Okay. Similarly, for oxygen also you can calculate. Okay. So again R is equals to R naught a power 1 by 3. R naught is 1.2 into 10 power minus 15 multiplied by mass number of oxygen is 16 power 1 by 3. So just do this calculation. Clear now? And these values you can take approximately now. Okay. For example, you can take 5 5 0, 25, 25 5 0, 125. So you take 6, 6 6 0, 36, 36 6 0, 190 something you will get. Okay, approximately you can take this value of 16 point something. Okay. So this also 2 2 0, 4 4 2 0, 8, 3 3 0, 3 3 0, 9, 9 3 0, 27. So it will be between 2 and 3. Are you able to understand? Like that you can take approximately the values. Okay. So the final answers which he gave is, for lead it is 7.1 into 10 power minus 15. 7.1 into 10 power minus 15 meters. And for oxygen it is 3 into 10 power minus 15 meters. 3 into 10 power minus 15 meters. So these are the answers. Okay.